We're going to go over Notes 5 today, which is solving multi-step inequalities, which is what we did a little bit of yesterday in Notes 4, and then also variables on both sides. So let's just kind of review what we did in Notes 4 in Assignment 4. You need to deal with the parenthesis here. So this minus sign, we can treat it like a -1. So we're going to bring down the 3x. And then -1 times x is -1x, or just -x. -1 times 7 is -7. And that's going to be less than 9. And then we have 3x minus 1x. We can combine like terms. So 3 minus 1 is 2. So this will give us 2x minus 7 is less than 9. Now we're here just with a basic two-step equation. We have a variable term, a constant, and another constant. So we need to get the constants on the same side. So we're going to move this 7 over. So the inverse of a -7 would be a +7. Whatever you do to one side, you must also do to the other. Bring down our 2x, bring down our inequality, and 9 plus 7 is 16. And the inverse of multiplication is division, so we're going to divide both sides by 2. And we have x is, the inequality symbol stays the same because the number 2 that we are dividing both sides by is positive. And then we can go up here to the number line, just a basic number line, put our 8 there. Since it's just less than without the equal sign, it's going to be an open circle, and less will be left. All right, number 2. It looks like we can combine like terms. So we've got our -6n plus 4m. Same signs, add and keep, different signs, subtract. So 4 from 6 is 2. Take the sign of the higher number 6, and it's negative. Then you'll be exact. Plus 5 is greater than or equal to 17. Basic two-step equation. Subtract 5 from both sides. So we're going to have -2n is greater than or equal to 12. We're going to divide both sides by a negative, so that should ring a bell. When you divide or multiply by a negative, you flip the symbol. Don't flip it too soon. Flip it on this last step. 12 divided by -2 is -6. So here's our -6. It does have a line underneath it, so it is going to be closed in, and it's less than, so it's going to go to the left. Now we're going to deal with variables on both sides. So it's very much like solving equations. Just make sure the variable ends up on the left side when done. It just makes it easier when graphing on a number line. So on number 3, we've got 5x plus 30. So this is a variable term, and that's a constant. And then over here on the right side of the equation, we've got -2, which is a constant, and 3x is a variable term. So we're balanced. So it really doesn't make any difference what you do. What I would suggest you do is to try to get your variables moved to the left first. So we're going to come over here and look at the 3x. So if we want to cancel that out, the inverse of a positive 3x would be a -3x. And whatever you do to one side, you do to the other. But make sure you put it over here underneath the 5x, since they're like terms. So now we have 5x minus 3x is 2x plus 30 is greater than -2. Now then, we have a variable term, a constant, and a constant. So this is just your basic two-step equation. We'll subtract 30 from both sides. So we have 2x is greater than, same signs, add and keep. And then divide by a +2. So we will not flip the symbol. And negative 32 divided by 2 gives us negative 16. All right, so we're going to come up here on the number line, put our negative 16, and it doesn't have a line underneath it, so it's going to be an open circle. And we want a number that's greater than 16, which will be to the right. All right, number 4, we have a couple sets of parentheses. So we're going to use our hippity-hoppity distributive property. So negative 6 times x is negative 6x. Negative 6 times negative 20 is positive 120. Less than or equal to, hippity-hoppity. 2 times 2x is 4x. 2 times 5 is 10. All right, it looks like we're balanced. So we've got a variable term and a constant on the left side. We've got a variable term and a constant on the right side. So again, it doesn't matter what you do, but I like for you to get in the habit of solving with your variable on the left side, so it makes it a little bit easier in graphing on the number line. So what we're going to do is we're going to eliminate the 4x on the right by subtracting 4x from both sides. And make sure that you line up your like terms. So here we have negative 6x minus 4x. So same signs, add and keep. And then bring down your 120 is less than or equal to 10. And now we're just looking at a basic two-step equation. We have a variable term and a constant and a constant. So I'm going to subtract 120 from both sides. So I have a negative 10x. Make sure you don't lose the negative with the 10. And 10 minus 120 is negative 110. And then divide both sides by negative 10. So that should ring a bell right there, that you're going to flip the inequality symbol, but we leave the line underneath it for our equal sign. And negative 110 divided by negative 10 is 11. So now when we go and graph it, over here on the number line, we have our 11, and it will be a closed circle, and numbers that would be greater than 11 would go to the right. On number 5, you notice that we've got a variable term and a constant on the left, and then a variable term only on the right. So to really balance this out, we would subtract 6x from both sides, but then that would leave our variable term on the right. So what you could do is just add a 0 here. So now that would make us balanced, where we have a variable term constant on both sides. And then what we could do is go ahead and subtract our 2x from both sides. This is just an option. 6x minus 2x is 4x. Minus 16 is greater than 0. And now it's just your basic two-step, because you have a variable term, a constant, and then on the other side you have a constant. So we're going to add 16 to both sides. So we have 4x is greater than 16. Divide by 4, divide by 4, and x is greater than 4. We don't divide by a negative. We didn't here. So our inequality symbol will stay the same. So we're going to come up here, put our 4. It will be an open circle because we don't have a line underneath it. And numbers greater than 4 would be on the right of positive 4. All right, let's go ahead and take a look at problem 6. Here we have a fraction. Don't freak out when you have a fraction. Just multiply and divide. So negative 2 times 3 is negative 6. Divided by 3 is negative 2x. Negative 2 times negative 6 is 12 12 divided by 3 is 4. Just as simple as that. Bring down the rest here. All right, so now we're balanced. We have a variable term constant on each side. So I'm going to move the variables to the left, which means I'm going to subtract 3x there and put the 3x, negative 3x, over here underneath the negative 2x. So same signs, add and keep. And you're going to keep that negative. Bring down the plus 4 is less than or equal to. Make sure you bring down the negative with the 6. And now this is set up for a basic two-step equation. So we're going to subtract 4 from both sides. Bring down the negative 5x is less than or equal to, same signs, add and keep. Divide both sides by negative 5. Now, when you divide by negative, remember our rule that we need to flip the inequality symbol. So it'll go from less than, and don't flip it until this last step. Because sometimes if you flip it too soon and then you're going to flip it back again and then it's back to the original. So make sure that you don't flip it until this last step. Negative 10 divided by negative 5 is positive 2. So x is greater than or equal to 2. So we're going to come over here and we'll put our 2 right there. And then it will be a closed circle, and numbers greater than 2 will go to the right. Okay, so here on the back side, we're going to work with specials with inequalities, but let's just go over what a normal answer looks like with inequalities. The number line graphs go one direction or the other. So in this situation, this would be x is greater than 6. And then over here, this would be x is less than negative 2. So those are what the normal answers that we have been working with. Now then, when we get in with the specials, remember that variables can drop out with the specials. So for instance, you might be left with 0 is less than or equal to 0, which is true. 0 isn't less than 0, but it's equal to. Or a statement like 15 is greater than 2. That's true. So these are true statements. Therefore, your answer will be all real numbers. Okay, and another, remember we said the abbreviation could be ARN or that fancy R, something like that. Okay, and it would be the entire number line. So all real numbers would work. Now then, when we get over here to the right side where variables drop out, is 4 greater than 4? No, it's equal to, but there's not an equal sign. Or is 5 less than 2? No, it's false. This is a false statement. Therefore, your answer will be no solution. And remember, before when we put no solution, we could put NS or a circle with a line through it. And the graph will be nothing on a number line. Over here, it's the entire number line. Okay? So you could put just the number line itself because it's the entire number line. If you need to get technical with it, it would look like that, meaning every number would work. But over here, there's not even going to be a number line. All right, so let's take a look and let's go ahead and work out some of these problems and see what happens with them. All right, so we're going to distribute hippity hoppity. Distributive property. So 2 times 3x is 6x. 2 times, now remember this is a negative 4. So 2 times negative 4 is negative 8. is less than 6x plus 10. So we're balanced. We have a variable term and constant on each side. So I've taught you to move the variables to the left first so that you'll end up with a variable on the left. So what happens here when you do that is they cancel out, which is what we've talked about. Is -8 less than 10, positive 10? I was about ready to put a -10. Okay, so -8 is less than positive 10. A negative is less than a positive. So this is a true statement. So therefore, it's going to be all real numbers. And if you want to do your R like that, something like that, you can. And then the number line would be like that. Okay? All right, let's look at problem 8 and see what happens here. So immediately, if you look on the left side here, is this will cancel out. You have a positive x and a negative x cancel out. Okay? So you're going to bring down 5 greater than 5. Well, is 5 greater than 5? No, 5 is equal to 5. So this is false. So therefore, this will be no solution. You could put a circle with a line through it, and then you won't have anything graphed.